Good morning. The topic that we are going to see is two-element array. First, we are going to see is what is antenna array, then types of antenna array, then what is two-element array, and advantage of using two-element array. Okay, first is antenna array. Antenna array. In many applications, it is needed. In many applications, it is necessary to design an antenna that has narrow beam, high gain, and high directivity characteristics so that it can be used for long distance communication. So what are necessary for long distance communication? Narrow beam, high gain and high directivity characteristics. So this can be achieved by increasing the size of the antenna. If the present antenna, if the size of the antenna is increased, then the gain will be more, directivity is also more. The one type of doing that is by increasing the size of the antenna or by using antenna array, that is using large number of antennas together. So these are the two methods this can be achieved. Then here, what is antenna array? Antenna array consists of multiple individual elements. Okay, multiple individual elements. Generally, antennas, multiple individual elements. In most of the cases, these elements are the array of identical elements. Okay, this is simple, convenient, and most practical. I'll show you the example here. So, see, as I told you, this comes multiple individual elements together, mostly identical. As I told you, multiple individual elements. So, all these are antennas. These are array of antennas. They are multiple individual elements placed together to form an antenna array. This can be same elements or mostly same elements. Some cases, different antennas are placed together to form an antenna array for communication. Okay, so this is very simple, convenient, and more practical. Here, these individual elements in the array most of the same are same, but few different elements are also connected together. Okay, here there can be single dimensional array or multi-dimensional array. If the array elements are arranged on only one axis, example only on x-axis or only on y-axis, then it is called a single dimension array. Else, if the array elements are arranged on a plane, example xy plane or yz plane or zy plane, then it is called as two-dimensional array, as I told you. Okay, so these are the most array elements that I use: half dipole, parabolic antenna, and turnstile antenna. Okay, these are multiple single antennas that are clubbed together to form array. Multiple single antennas clubbed together to form an array of antenna. That is what called as array antenna. Okay, type of array antennas. There are generally four types of array antennas based on their position, shape. There are both based on the position and shape. Based on the position and shape of each antennas, there are four types of antennas. That is linear array, circular array, and planar array, and conformal array. Conformal array. Okay, we'll see that. So this is linear array, circular array, planar array, and confrontal array. So in linear array, the radiating elements, these radiating elements are arranged on a single line. Then it is called as linear array. If the radiating elements are placed on a circular pattern, then it is called as circular array. Then planar array. If the array elements are placed in two-dimensional grid, example xy plane, so it is placed on two-dimensional grid, then it is called as planar array. Last one, conformal array. If the array elements are placed in 3D, three dimensions, okay, then it is called as conformal array. Then array antenna. The total field of an array is determined by the vector addition of the field radiation of individual elements. That's nothing but total field of the array. The total field of the array depends upon the addition of individual radiating element. And if you add the individual radiating element, then you will get the total field of the array antenna. This is assumed that each array element are given same amount of current is being supplied. It is generally assumed so. So to provide why it is same amount, so that to provide directive pattern, so that it is necessary that the field of the element of the array interferences at one point and diverge cancels out at each other. Interference It had interference constructively and interference destructively. Two types. Interference constructively means the array elements add to each other so that the directivity is more in one direction, whereas in the other direction, the array elements should cancel out each other so that there is no radiation in that particular direction. So that directivity of the array element will be more. Okay. In the array element, generally 5 controlling elements are there in the array element, that is the geographical the geographical configuration of the overall array. Geographical configuration here. This is the geographical where it is being placed based on the geographical construction, that is linear, circular, planar, or rotational. Based on that geographical construction, it can control or relative displacement between the elements, the distance between each element you can control, or or exciting the amplitude or exciting the phase of individual element. The last one is relative pattern of individual elements. Based on all this, the array elements can be controlled. Okay, advantage of using array element. If the overall gain is high, reception directivity provides diverse reception. That is, directivity is good in the reception, cancels out interference, maximum signal to ratio is attained. The focus of the antenna, that can focus the antenna radiation pattern wherever you want to. This is the two-dimensional array. Thank you.